Okay, let's try this sec. Let's try sec x. How do you differentiate sec x to get this result? Sec x, when you differentiate it, you are getting sec x tan x. So you can use it directly if you can recall it in an examination. So you can see the way we did tan x in the last video. So let's see how we can do for sec x. So let's start. If I have the function like this, say y is equals to sec x, then how do I differentiate it? Let's move on. Remember, let me review the ratio again. So when you look at sec is what? Sec is 1 over cos. You can see it. Sec is 1 over cos. So that means that is what I need to replace with this. So I'm going to have y is equals to 1 divided by cos x. So you must go to this trig identity or s. It will be difficult to differentiate it. So now that I've turned sec to be 1 over cos x, so what am I going to do? So we are going to use a quotient rule. So using the quotient rule now, so using your quotient rule, so don't forget this quotient rule is very important. So if you use the quotient rule, which is this, you can see it there. So this is the quotient rule, which is the numerator is u, the denominator is v. That is it. Then this is the formula for quotient rule, dy dx. So this is the x. So dy dx now is going to be v times du dx minus u times dv dx all over v squared. So we use it when we're differentiating tan x. So we don't need to talk much on this. So if you move straight to the answer, remember the numerator is u, the denominator is v. So if numerator is u, so differentiation of u is something like this we are talking about. It's going to be u divided by v. So that is it. Then u is what? U is equals to 1. And you know it's a constant, du dx. Du dx is equals to 0. Differentiation of a constant is 0. Then the denominator is v. So v is equals to cos x. V is equals to cos x. And differentiation of cos x, that is dv dx. Dv dx is equals to minus sine x. So when you substitute this into this formula, you see the answer will show itself. So you have dy dx will be equals to cos x, which is v, du dx, see, times 0, then minus u, which is 1, times dv dx, and it's going to give us a negative minus sine x. You can see it. Then everything divided by the square of v, which is v squared, and that is cos square x. Then let me conclude it on this corner here. I conclude my result here. So this is going to be 0. That is dy dx. Dy dx is equals to, you have 0 on this side, so let's ignore that, times minus sine x, which is minus sine x divided by cos square x. Cos square x. That's cos square x. You can see this is 0 times, okay, sorry, this is 0 minus 1 times minus x. So minus times minus should be plus. So this place is going to be plus. Very important. You can see it. Minus times minus is plus. So let's conclude now. Let's go to the next one. So dy dx is going to be equals to what? So dy dx now. So this is sine. So sine x divided by cos square x. Let's see how we can split it into 2. So if I split this place as something like this now, 1 divided by cos x times sine x divided by cos x. You can see, this is the denominator. Cos x times cos x is cos square x, and 1 over cos x is what? If we go to our identity, you can see 1 over cos x is sec x. So I'm going to have our final result now, which is dy dx. So dy dx will be equals to sec x times sin x over cos x is the same thing as tan x. So that is the final result of differentiation of sec x. So in differentiate sec x, you can see the answer is sec x tan x, and I know that is the same thing we got in that table. You can see it, sec x tan x, differentiation of sec x. You can see. So this is all we need to do when we are differentiating. There's nothing so special about it. All I want you to learn from here is you can try the other values. You can try cot x. Cot x is what? Cot x is tan x, 1 over tan x, which is the same thing as cos x over sin x. You can get it from the identity here. You can see cot x is 1 over tan x, and what is tan? Tan is sine over cos. Therefore, cot x is cos over sine, which is the same thing in this number 3. You can see cot is cos over sine. You can do the same thing using your quotient rule. If you use your quotient rule, you will get the same result, and that is that. Then you can do the same thing for cosec. So what is cosec? When you go to your review table, you will see that cosec, you can see cosec here. Cosec is the same thing as 1 over sine. So you use your quotient rule, differentiate, you will get the same result. So this is all I have for you for differentiation of trigonometric function. So this is the summary of differentiation of trigonometric function. So in our next video, in our next class, I'm going to differentiate exam questions. I'm going to use our past question, YF, further maths question, and JAM mathematics question, differentiation of trigonometric function. Though when you are asked to differentiate trigonometric function, there are other steps you can apply, especially when other values are added to it. So I will show you all that in our next video. But for now, these 6 basic functions, this is how we differentiate them: sine to cos, cos x to minus sine x, tan x to sec square x, then sec x is sec x tan x, then cot x is minus cosec square x, then cosec x will give us minus cosec x cot x. So these are the 6 basic trigonometric functions, and this is how you differentiate them. And that is all for now. So go through the videos we have done so far, look at the way I differentiated them. Then on your own, I want you to practice the following. You can use first principle to differentiate cos. Just follow the video I used for differentiating sine. You can do it, you will get the same result. Then do the one for cot and do the one for cosec x. You will see that you will get the same result. So that is all I have for us for now. So do have a nice day and take care.